Whew, okay. What are we doing? We are talking about the abacus. So what are we doing? How are we going to do it? We're going to count. How are we going to... Okay, anyways. All right. What are we going to do? We're going to be counting on the abacus. This is what we're doing. We're counting on the abacus, so we're doing 1, 2, 3, 4, knowing that this is a value of 4. 4, and then we have 5. After 5, we have 6, 7, 8, and then 9. Great. Are we done? Yep, we're pretty much, that's it. So after 9, we have 10. 10 is a 1 and a 0. Because 10 and a 1 is 0, oh, that's not, let me maybe make that better. There we go. So if you notice, every place value has a column. Every column is a place value. We have ones, tens, hundred, thousands, 10,000. Cool. So when we're counting, we do 1, 2, 3, 4, and then 5. 6, 7, 5, 6, 7, right? The top bead will always be 5. And then we have 6, 7. And then we have 3 plus 5 is 8. And then we have 4, right? We have 4. And then when we add the 5, we now have 9. After that, we can do 10. 10 looks like that. So we're going to count it again. We're going to do a review. Let's do a review. Let's do a review. So when we're looking, the idea is to understand how to read the abacus. Oh, thank you so much for liking the live. Thank you so much. Okay, what are we doing? What we're doing is we're reading the abacus. We have 0, 0 means that none of the beads are touching the horizontal bar. This is the horizontal bar, so that means they're not touching the horizontal bar. When one bead touches the horizontal bar, now this is called 1. After 1, obviously, is 2. This is 2. How do we know? 1, 2. 2 beads, 2 items. So if I just did 2 pencils, that's what 2 is. 2 items. Just like here, we have 2 snakes. We have 2 snakes. Because we have 2 snakes, we have 2 on the abacus. We have 1, 2. And then we have 3, well, it looks like 3 chipmunks. When we have 3 chipmunks, we have 1, 2, 3. 1, 2, 3 on the abacus, 1, 2, 3 on the paper, right? We have 3 chipmunks. And then we have 4 big koalas. After big koalas, we have 4. We have 1, 2, 3, 4. 1, 2, 3, 4. Oh, I can't see that. There we go. There we go. Better? When we're looking at how to read the abacus. We have 1, 2, 3, 4. Okay, that's great. We're done. No, we're not. We're not, because now we have 5. We have 5. After 5, right? Well, how do you do 5? Well, 5 are what? 5 horses? Well, in this case, 5 is the top bead. The top bead will always be 5, no matter what. 5 is the top bead. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 will always be the top bead. And then we have 6. 6 is what? If you notice, it's 5 plus 1. 5 plus 1 is 6. 1, 2, 3, 4, 5, 6. 6 sheep. And then we have 7. 7 crocodiles. 7 crocodiles, right? How does that look like on the abacus? We have 5, 6, 7. 7 on the abacus, 7 crocodiles. And then we have 8. 8 pink bunnies. I don't know when the bunnies became pink, but we have 8 pink bunnies. So we have 5, 6, 7, 8. What we're doing is we're learning how to read the abacus. So we have 1, 2, 3, 4, 5, 6, 7, 8 bunnies, and we have 8 on the abacus. And then we have 9. After 9, right, we have 9 cows. We have 5, 6, 7, 8, 9. This is 9 on the abacus. These are 9 cows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well then, what about 10? Well, 10, right, the way we write 10, if you notice, is a 1 and a 0. Because 10 is a 1 and a 0, we're going to do 1 and a 0. What? Why? Because every column is a place value. So if you notice, this is my ones, this is my tens, hundreds, thousands, 10,000s. When we're looking, we can now count by tens. We have 10, 20, 30, 40, and then 50. After 50, we have 60, 70, 80, 90, right? Let's go back. If we do 10, that's what 10 looks like. And then this would be 11. And then after 11, this is 12. And then obviously we can count higher, right? 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Maybe I should write it out. So we have 10. Notice 10 is part of the tens. What is it? Tens, right? And then the ones. Oops. When we look, if this is a placeholder, 0 is a placeholder. On our abacus, every column is a placeholder, right? Every column is a place value. So we have 1 and 0. And then when we do 11, we have 11. What does that mean? Well, just as we have tens and ones, we can do 11. If we do 12, when we do 12, we can do tens and ones. So that would be 12. What are we doing? We're just counting on the abacus right now. 13. I have tens and ones. So this would be 13. 13 would look like that on the abacus. And I'll just keep going down. So anybody have any questions, let me know. We're going to continue on to adding and subtracting, multiplication and division. I don't know if we can get to division, but the biggest thing is understanding how to add, subtract. And then we have 14. Because we have 14, that's what it looks like on the abacus. And then, wait, 15? 15. We know what 15 looks like. 15, right? Ones and tens and ones. Tens and ones. This is 15. 15 is the top beat. It will always be the top beat no matter what. So we have 15, and then we can do 16, right? 16, like that. So we have our tens and our ones. So 16 looks like that. Why? Because we have 1 and 6. 6, 5, 6. 5, 6. That's what it is. First, Fargo, almost. North Dakota Tango 0 done. Yep. So if it's 0, that would be 0, right? And why? Because none of the beads are touching the horizontal bar. When we're looking, right, when we add it, this would be 1. If we did this, this is 10. If I did this, if I did that, this would be 100. How do I know? Because I have my place values. When we're looking at our place values, we have our 1, we have 10, 100, 1,000, and then 10,000. We're reviewing how to read the abacus. So if I did this, this would all be 1. 1, 1, 1, 1, 1, 1, 1. We could do 2. That's what 2 looks like. 1, 1, 1, 1, 2, 1, 1. So if I move everything else to be 2's, now we have all 2's. And then we have 3's. 1, 2, 3. But none of these are 3's. I'm going to make them all 3's. If I do this, now they're all 3's. DJ! We have returned. We have returned. How are you today? We have 4, right? This is 4. 1, 2, 3, 4. But all of these are 3's. Because these are 3's, and then we have 4, let's make it all 4's. This is what 4 looks like. And then we're going back to 0. But we want to do 5. 4, right? That's 4. This is 5. So I'm going to move all of these down to 5. And then we have 6. So these are all 5's, and then we have 6. I'm just showing the difference between the two. It's always just the one bead, right? So when we're looking, we have 6, 6, 6, 6, 6, 6, 6, 6, 6. And then we have 7, 5, 6, 7. And I'm contrasting between the 6 and the 7. It's only extra one bead. What we're looking for is to also look at the number pattern. So we know that this is 7. 5, 6, 7. 5 plus 2 is 7. And then if I do this, this is all 7's. And then we have 8. If I make this all 8, and then we have 9. And after 9, right, these are all 9's. Now what are we doing? Well, now we can start talking about our place values. We understand what the numbers mean, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that this is 9. So then what's 10? 10 looks like this, just as we write. How we write 10 is exactly the same as we read on the abacus. This is not 10. This is 55. Why? Because these are the values of 5. This is the value of 5. This cannot be 10 plus 10, 5 plus 5. 5 plus 5 is not, this is not it. 10 looks like this. Make sense? So, if there's no, hey Jeffers, welcome back. I just looked up and I'm like, oh my gosh, there's a lot of people here. All right, so what are we gonna do? Let's do some mazes. Are we ready for some mazes? Hello. Oh, you know what? Okay, let's do some mazes for double digit. Are we ready for that? Or do we want to do 3 digits? We can do 3 digits. I think I have that ready. Those are my favorite. Really? I'm so excited. I didn't think anybody would really like it. I'm so excited. You know what? You want to do 3 digits? We could do 3 digits because I'm getting that ready for publishing. Let's see if I can find it now. Yeah, I didn't think anybody would enjoy it, but yeah, I think it's kind of cool. All right, so what are we doing? Let's do 3 digits. I just need to find it. I found it and then I lost it. Oh, here it is. Okay. There we go. 3 digits. Let's see how we do on the 3 digits. We're going to start from here again. Right? I never thought that 37 of you learning how to use the abacus. Or 37 we're learning how to add and subtract. That's all right. That's all right. We all got to start from somewhere, right? That's all right. That's all right. It's fun though, because the thing is like it actually, like, I like it because it's like provides a puzzles. It's like a puzzle for me. Okay, so we have this number. If I have my ones, tens, hundreds. Yes, 233. Thank you. It is 233. How do I know? Because of my hundreds, my tens, and my ones. When we're looking at our place values, right? We have our ones, our tens, our hundreds. And we have 1, 2, we have 1, 2, 3, 1, 2, 3. Thank you, Jeffers. So then we come down here. What number do we think this is? So I have my tens, I have my ones, my tens, my hundreds. My ones, my tens, and my hundreds. What number would that be? 53. Thank you. It is 53. Yeah, I do like it. I do like it. But then I'm like, I'm going to do, so this is the 3 digit. I have one that's 4 digit as well. And then 5 digit. But the 5 digit will have a decimal. And so I'm not sure if I'm going to keep the same size because it gets a little big. I don't know if this is big enough or too small. My eyes are old, so. Okay, so if I have hundreds, tens, and ones, if I'm my hundreds, that's my hundreds, this is my tens, and then this is my ones. What number do we think that is? Now, if we count it, we count from 5, 6, 7, 8, 9. So all together is 9 on the ones. If I count here, 5, 6, 7, 8. So this is 8. And then we have at the hundreds, 5, 6, 7, 8. Thank you, Jeffers. It is 889. Thank you, Pay. Thank you, Pay. Welcome, welcome, welcome. So we have 889. And then we have this number. We have our ones, our tens, our hundreds. When we look, we will have our hundreds, right? We have our hundreds, this and this. We have our tens, that's tens, so this and this, right? And then we have our ones. It'd be all of these. What number do we think that is? Oh, right? 1, yeah, wait. Hundreds, tens, and ones. Thank you. Thank you, Pay. Thank you, Michael. 284. Thank you. Hey, Laura. Welcome. Thank you, Jeffers. Yes. So 284. And then we come down here. So the reason why, okay, so here's a few things. The reason why I made it hollow is so then you can color it in. I like to color it in with a highlighter just because it doesn't cover up the whole number. So if this is my hundreds, right? This is my hundreds. Here's my tens. My tens are here. And then this is my ones. and that's my ones. What number do we think that is? Oh, good. Thank you, Jeffers. Because why? 5, 6, 7, and then 2, 1, 2. Thank you, Michael. And then 5. This is the value of 5. Hello, pay. Pay, no, pay. So pay would be 625 would be 6. That would be 6 because it would be, oh, thank you. You got it. Probably a typo. Because of why? That would be 6 because 5, 6. So that's 700, and now we're here. My hundreds, my tens, and my ones. So my hundreds, my tens, and my ones. Actually curious, what's the purpose of learning the abacus? Hey, Crush. Orange. The reason why, usually it's for kids, but for adults it'd be like brain gymnastics, because you know, like you have jigsaw puzzles and Sudoku and crossword puzzles and word searches, all that sort of stuff, then that would where abacus lies if it's for older people. And it's like just brain gymnastics, and it really gets your critical thinking going. But for the younger kids, what it does is it really provides a solid arithmetic foundation, such as adding, subtracting, multiplication, and division. And there's different strategies that are in mainstream, but in abacus we use formulas, and the formulas is what gets solidified. And because we know the fact families of the numbers, we can get really solid in adding, subtracting, multiplication, and division. Did that make sense, Orange? Oh, I'm done with that. So we have 144. Thank you, Michael. 144. Did that make sense, Orange? Yeah. Yeah, not a problem. You know, people ask, and I do appreciate the preface of actually curious, because some people are not, and they're just kind of like, you know what I mean? But yes, thank you. I do appreciate it. And so, yes, exactly what Jeffer says. It's a visual. It's a visual way of seeing things. Steady visually is great, instead of constantly asking them to imagine. I think that too, but also the difference is you can actually see the numbers, and I can show you when we start adding bigger numbers. When we add the bigger numbers, we can see if we can add it or not. If not, then we can know how to use like formulas, which is like just critical thinking, if that makes sense. Can we get rapid fire problems? We can, but I'm not set up for that. I'm not set up for that. Because I'm not set up for that. I would have to figure that out, because I would have to I'd have to share my screen, and then we could do it. But then, yeah, I don't know. I'd have to figure that out. Maybe I don't know. Like I could do so instead of doing this, so okay, we have 365. Okay, 369. So if I did that, okay, then I would have to show you this, right, Jeffers? So if I did this, I don't know. I'm not set up for that. Yes, it is 369. But then I can't, because the abacus, I have to move the abacus. I don't know. Or I give you a picture of the abacus. I could do that, like pictures of the abacus. Like, what number do you think this is? I don't know, right? DJ. Almost. Because it's 8. 5, 6, 7, 8. And then 1, and then 2. Thank you, Jeffers. Yeah? DJ's would be this. 912. 812. Yeah, I'd have to figure that out. But see, the thing is I would have to give you pictures of the abacus, not numbers. Because giving you numbers, you can do it any which way. It doesn't matter, you know what I mean? I'd have to figure out how to show you what the abacus looks like. Yeah. 97. Thank you. Yes, thank you, Jeffers. 97. 5, 6, 7, 8, 9. 5, 6, 7. Good. Thank you, DJ. Thank you, Michael. Yes. So then we have this. Yeah, I'd have to think about that a little bit more. Now I'm just thinking. If I have my hundreds, tens, and ones, thank you, 114, 410. Yeah, we're all right? So 410, and we're over here. Whoa. Hundreds, tens, and ones. Thank you, DJ. Yes, 410. It is 410. Yep. 296. 200, 1, 2, 90. 5, 6, 7, 8, 9, and then 6, 5, 6. Yep. Thank you, DJ. Thank you, Jeffers. So 200. Oh, we're at the end. So we are just about done. So we have hundreds, we have our tens, and we have our ones. What is our final answer? Survey says 311. 311. That's funny. All right. Sorry. Yeah. So that's the 3-digit. And then I was going to do the same thing with the reverse maze, but I don't have a picture of that yet. So the idea was here to understand how to move the beads. Now we understand how to read the beads. What we're going to do is we're going to understand how to move the beads. But if it's just the two of us, if it's just the three of us, I'm not sure. Laura, are you still here? We can talk about anything else, but I'll just continue on. Have you done all multiplication yet? We did. You want to do multiplication now? How are you doing? We could do multiplication right now. Because it's just the three of us or four of us, depending on, unless we want to go into adding, subtracting. Yeah? Okay. Let's do it. I was able to curate some of them. Where do I buy a book like that? You know what? I have one more and it's in my shop, or you can find it here. I do have it available. My name is Lynette. Hi, my name is Lynette. I am an Abacus teacher. I've been an Abacus teacher for 20 years, and I enjoy teaching Abacus to everybody. You can find my books here, or you can find my books in the TikTok shop. I do offer, I'm like on my, yeah, I do offer services like online classes and tutoring. I also do provide workbooks, and all the workbooks I have do have instructions on how to do things. So, thank you. Yeah, no, not a problem. Thank you. We're gonna do multiplication. We'll do this multiplication, and I'll show you how to do distributive property. Yeah, not a problem. Thank you. Thank you for asking. I do appreciate that. And so yeah, if you want to buy it there, or you can buy it at the shop. I am trying to build my shop. But I gotta, yeah, anyways. So the first thing we're gonna do is we're gonna do some multiplication. Okay, here is the question. I need to find, here we go. We'll just do that. All right. How quickly do kids pick it up? They pick it up pretty quickly. Meant to ask you if your online classes were meant to adults. No, it not right now. It was not meant for adults. I didn't even think adults wanted it. But I can have it. It would just take some time. You know, the biggest thing what's stopping me from making an adult one is to curate all the questions before I can publish it. If that makes sense. The reason why is because what it takes time to curate the questions. As you see, the questions are very specific. I do plan on doing a boot camp because I don't think having an online class for that amount is beneficial. So if I was to do a boot camp, I was thinking it was going to be maybe uh, eight 8 weeks. So I was thinking like an hour a day, and it would go from multiplication, adding, subtracting, multiplication, division. That's what I was thinking, and then I would provide, and there would be worksheets available. But that's what I was thinking, doing a boot camp. What do you think? It would be maybe a weekend, or maybe it would go for a few days, maybe like an hour a day. That's what I was thinking. I'm not sure. Really? Really? Okay. Yeah. Cuz the reason why I'd say about 8 hours is I was giving like, because the questions would be longer, right? It would be like one digit, 2 digit, 3 digit, 4 digit. I'd go 5 digits, and it all depends on how long. So it would take time. I mean, for the amount of like a weekend or 2 days, yeah, maybe a weekend or 2 days. Yeah, it really does depend on how much I can curate, as well as the, maybe, I don't know. If I do 2 days or do a 3 day, that's a few hours, I think, in a couple of days, right? I'm not thinking an hour. I was thinking an hour a day, and that would be maybe a week. But I don't know if that's too long. The reason, and then if I do this, then I can use it as a teacher's boot camp as well. So then the teachers will be able to take it, go through this boot camp. How quickly do kids pick it up? As quickly as they can go through adding and subtracting. So, like, if you think about first grade, they do adding, subtracting, all the way to what, double digits. So it would be interesting. Sorry, I'm just reading. Um, so so it just depends on how quickly they go. It depends on how far you want the kids to go. Sorry, I'm reading about Jeffers' question. So it depends on how far you want them to go. It there is a whole like the whole curriculum. Like my kids went through a whole curriculum, and it took them about 4.5 years to go through it. 4.5 years to go through the Abacus curriculum, but that's like an hour a week kind of a thing, and then they would just practice. If that makes sense, I don't know, like how quickly they can see it. I'm sorry, I do. I mean, they could see the abacus and stuff. They understand how to move it, but a lot of it is just practicing and practicing and practicing, just like we do in regular school. Is that we keep practicing. I don't know if that answered your question, Jeffers. That's yeah. My brain suddenly stopped working. Yeah, mine too. When I get questions, like, it's really interesting. Okay. Yeah, yeah. Okay. Thank you. I appreciate that. Okay, so the first thing we're gonna do is 4 times 58. Yeah, my kids start school is gonna end school pretty soon, so their brains are gonna stop working very soon. All right. So the first thing we're gonna do is understand the where we're gonna put our abacus. But I appreciate the questions. It does give me a lot to think about, like how to navigate through the demand of abacus. So I do appreciate it. So the first thing we're going to do is understand where we're going to put our numbers. Here is our question: 1, 2, 3, 4. So we know we're going to go 1, 2, 3, 4. Because we're going to go here, that's where my answer is going to be. Because my answer is going to be right here, I'm going to end up here. Now the reason why is because if you look at it, we're going to be doing 20 times 50. But that's not what we're going to do. Colors and numbers? No, Gia. No. If we want, we can change it to this. It's positioning. Thank you, Gia, for the question. It's all about positioning. So we have 5, right? The top beat is 5, always, no matter what. So when it touches the horizontal bar, this would be 5. We can do 6, 7, 8, 9. Yeah? So no, numbers is not the colors. Here. So now we're back to here. So in Abacus world, we actually don't do it this way. What we do is in Abacus world, actually do 2 times 5. That's what we do. Why? Because the abacus keeps track. That's why we count where we go. 1, 2, 3, 4. If you notice, my answer is 10, right? 1 and 0. This is what we do in multiplication facts, right? But if you notice, we have to do it this way if we write it on paper. When we times it, it's 1,000. But if you notice on the abacus, we already have it as says 1,000. How do I know? Because right here is my ones. So when I look, I have my 1 and 0. This is my 10. And then what do? I did this, and now I do this. So the next one is 4 times 5. Now if is equal to 20. Plus 2 plus 0. If you look, if I change it to the mainstream, right, it would be what? 4 times 50. 4 times 50 is 200. So what we're doing is we are looking at the difference between new math and abacus math. So 9, is that 9? 9 looks like this. 5, 6, 7, 8, 9. When all the beads are touching together, that's what 9 looks like. So what I have right now is 1, 2, 0, 0. 1,200. So again, when you look, we don't need to write out the zeros. We just need to know our multiplication fact. 3, no, this is 1, this is 2. 3 looks like this. When you put it all together, that's what 3 looks like. When we're separating it like this is 1, this is 2. So we're done with the 5. Now what are we going to do? We're going to recount it. 1, 2, 3. So I know 1, 2, 3. I know I'm going to be over here. We're going to do distributive property. So we're going to do 8 times 2. What is 8 times 2? 8 times 2 is 16. You don't add, then it's their own position of the value. 8 times 2. Thank you, Jeffers. Yes. I got 8 out of, yeah. So 16. Add the 1, add the 6. So again, we're not going to do, right, is 8 times 20 is equal to 600. Because why? If you notice, Abacus keeps it already. 160. Oh, sorry. 160. That's a 60. But we don't do it this way. We just keep up with this way. Why? Because this is what we do in in multiplication facts. So the next number we do is 8 times 4. 8 times 4 is 32, right? Add 3, add the 2. Thank you, Jeffers. So my final answer is, can anybody tell me what my final answer is? Did that make sense, Laura? Yes, 1,392. Yes. Yeah, good. Thank you, David. Thank you, Jeremy. Thank you, Clash. Oh, not 4. Not 4. That's is what 4 would look like. Now we have a 9. So it's 1,390, 5, 6, 7, 8, 9, and then 2. That's what that is. Yep. Yeah. No, thank you. Thank you for the comment. Yes, thank you. Right? So when we're looking, I don't know what Gia is trying to do, but so that's multiplication. And when we look, we could do another one. But again, it's a lot about like making sure that we go through multiplication facts. So Laura, yeah, we could do another. But just so you know, the kids need to memorize their multiplication fact. They don't need to do it this way, but they need to do the multiplication fact. Oh, thank you for the headband. Oh, D family, thank you so much for the head garland. I just saw that. Thank you. I just looked up and it'd be like, oh, hey. Thank you, D family. Thank you so much. I appreciate that. Okay, yeah, let's do another one. Let me do another one. So we can do, okay, let's do an easy one. We can do 93 times that by 8. I just learned this less than 3 minutes. Thank you so much. Clash. Yeah, you're welcome. You're welcome. Is this a new process for math now? No, this is not a new process for math. This is Abacus math. Abacus math is very old. Abacus is very old, and it just happens to be a forgotten tool. All right, so what are we going to do, right? That's my hubs. He's been interested. Oh, really? Oh, okay. I have to be careful, like, you know. Oh, I see. DFAM. Oh, fantastic, fantastic. I always want to learn this. Yeah. It's really quite easy. It just depends on like how it's presented. So, thank you so much, everybody. Thank you so much for the presents. Thank you so much for the gifts. I appreciate it. Okay, so what are we gonna do now? We're gonna go back to the colorful one because I do like to see the colors more. I feel like it's a little bit easier to see. So the first thing we're gonna do is we're gonna understand where are we gonna put our answer. 1, 2, 3. We're gonna count 1, 2, 3. When we see this, what are we doing? We do 9 times 8. Right? We are not going to do 90 times 8. This is not what we're going to do. Good, right, Jeffers? Yeah, that's what I'm saying. It's easy to do, and then as you go through it, you're going to see that there's a pattern. So what is 9 times 8? 9 times 8. 9 times 8 is what? 72, right? So I add my 70, and then I add my 2. Now what do? I do 8 times 3. Thank you, Jeremy. Thank you, Jeffers. 8 times 3. Oh, 8 times 3 is 24. Thank you. So I add my 2. Is there enough to add the 4? Yes. So all I have to do is add my 4. So my final answer is, right? Thank you, Laura. Right? What's my final answer? 744. Thank you, Laura. Thank you, Jeffers. 744. So that's my final answer. 744. Obviously, single digit multiplication is a little bit easier because you don't have to do too many formulas. We can do another one because I curated the questions. I curated the questions ahead of time. So then they're easier to see. I was too slow. I will go slow too, right? So we can do another one. We'll do another one. We can do 3 digits times 1 digit. That would be easy. So now you understand, right? You understand this, right? We don't need to do 90 times 8. We don't need to do 20 times 50. We don't need to do any of that. We just need to know our multiplication fact. That is all we need to do. We know our multiplication fact. We're set. So it's just the same thing as understanding how to add the 5 and how to add the 5 and take away the 5. Add the 10, take away the 10. So we have 800 times that by 7. So what are we going to do? What is our starting point? I'm going to do that. There we go. What is our starting point? Where are we going to put our answer? We're going to count it, right? We count 1, 2, 3, 4. Thank you. 4 digits. 1, 2, 3, 4. So the first thing we're going to do is 7 times 8. Right. Thank you, Clash. Yes. 4. Yes. Thank you, Laura. 56. Thank you. 50 and then 6. So I move my finger here, right? The next one we're going to do is 7 times 5. 7 times 5 is, oh, a little crooked. 7 times 5 is 35. Yes. So you add 30, you add 5. You add 30, and then you add 5, right? 35. And then what's next? 7 times 3. 7 times 3 is equal to 21. Thank you, Jeffers. Thank you, Laura. So we add my 2, and we add my 1. So what is my final answer? Right? Easy? This is easy because we know how to read the abacus. Yes. 500, 9, 7, 1. Yep. Thank you, Laura. Thank you, Clash. Yes. Make sense? So what this means is we're just understanding how to move the beads, and as we move the beads, we know how to do it with multiplication. Should we do another one? I have one more, and then I'm done. We'll do one more. And then I have to go look for my other ones, how to I built an application. So, where were you when I was in school? You guys are so silly. No, I appreciate that. So when we're doing it, right, oh yeah, here's another thing. There was another epiphany we made. There's one. All right. So here in Abacus world, right, this is how we do it. We do distributed property. But if you notice, if I did mainstream math, we did mainstream math, 4, 7, 5, 4, right? And what do? We do 4 times 4 is what? 16 carry 1. 4 times is 29, right? And then we have a 0. Do you know why we have a 0? Yes, we'll do that. Thank you, Mr. Clean. Hey, Mr. Clean, welcome. Okay, so why do we have a 0? The reason why is because we're timesing 50 by 4. So we're actually doing 50 times that by 4. This is why we have a 0. Yeah, that's the only reason. And then you carry on. But that's the interesting part about mainstream math. Okay, so it's actually easier to do it on the head instead of trying to stack cross-multiplying that. Yeah, exactly. And yeah, I think maybe because you do it in your head because you see the place values. So, 12 times. Okay, Amazing teachers are really my. Oh, the one and only. I'm sorry that you have a poor experience with teachers. Placeholder. It's a placeholder, just like a 0 is a placeholder. Like 50 is a placeholder. We're actually doing 5 times 4. That's what we're doing. 50 times 4. But doing this placeholder, it doesn't make sense. There was another person said that they use an X here. All right. So, okay. Thank you, Mr. Clean. I put that in the notes. We will do this first. Yeah? So the first thing we're going to do is understand, where are we going to start? We're going to start here. 1, 2, 3, 4. Right? 1, 2, 3, 4. 5 times 7. 5 times 7 is equal to what? Is equal to 35. Thank you, Jeffers. So I add my 3, I add my 5. And then what do I do? 5 times 4. 5 times 4 is equal to 20. So I add 2. I can add 2. 0. All right, we're done. We're done. So I'm going to do another color. When I do another color, I'm done with the 5. What I'm going to do, I'm going to count it again. 1, 2, 3. 1, 2, 3. So I'm over here. Next one is 7 times 4 is equal to 7 times 4 is equal to 28. Add my 2, add my 8. And then I do 4 times 4 is equal to 16. Add the 1, add the 6. So my final answer is, what is my final answer? $3,996. Thank you, Clash. Thank you, Jeffers. Yes, right? So that's the answer. 3,996. Okay, so I'm not sure what we're doing here, but we're going to do it. And hopefully you guys can keep up with the whole adding and subtracting the 5. Now the first thing we're going to do again is we're going to what? We're going to figure out our starting point. We have 1, 2, 3, 4. 1, 2, 3, 4. The first thing we're going to do is 3 times 1. 3 times 1 is 3. To make 3 a double digit, we're going to say 0, 3. So that means 0 and 3. And then what are we going to do? We're going to do 3 times 2 is equal to 6. 6, again, is a single digit, so I'm going to do 0, 6. So 0, 6. So we're done with our 3. Now what are we going to do? We're going to do our 8. Okay, are we ready? 1, 2, 3, right? 8. 8 times 1 is equal to 8. 8 is a single digit, so I go 0, 8. We know this. So 0, 8. We need to add the 8. Can we add the 8? No, we can't. What is another way to add the 8? Do we remember how to add our 8? 8 is equal to plus the 10 minus the 2. Okay, good. Plus the 10 minus the 2. Thank you, Laura. Thank you, Mr. Clean. Question, can I take away the 2? No. If I can't take away the 2, what do I do? If I cannot take away the 2, what do I do? Minus the 2 is equal to what? Yes, thank you, Mr. Clean. Minus the 5 plus the 3. Minus the 5 plus the 3. And then what do? 8 times 2. 8 times 2 is equal to 16. What do? I add my 1, I add my 6, I add my 1. Can I add 1? How do I add 1 here? Plus the 1 is equal to what? Plus 1 is equal to what? Thank you, Mr. Clean. Plus the 5 minus the 4. Plus the 5 minus the 4. And then plus the 6. So my final answer is here. Final answer is what? 4, 5, 6. Did that make sense, Mr. Clean? So the difference is, thank you, Laura, yes, 4, 5, 6. 4, 5, 6, yes. So the difference is what? We had to start using our simple information. are adding and subtracting, but are adding the 5 and taking away the 5. Yeah, it can get complicated. Yeah, not a problem, Mr. Clean. Was that a question that you were looking at in school? But it's different, right? Now, I gave you the beginning parts. This is like simple, right? Easy. Now, when we start adding and subtracting, we need to understand our fundamentals. What's the next live to cover for simple part? When's the next live to cover the simple part of information? Clash, it's every live I do is always cover simple. It just depends on if the if my older students come in and they start asking advanced questions. Mr. Clean has been with me for a little bit, so he's pushing the whole class forward. It's all my lives is all the lives I start off with is always simple. But then depending on the older students as they come in, because I've been on live for about a few months now. And so now I'm having some repeat students that are coming in that are a little bit that have been with me for a little bit. So we go through all of like adding and subtracting of the 5, adding and subtracting of the 10, and then we start getting into multiplication. That was too fast. I am remedial application class. Oh, okay. So then going back to this one would be easier, right? Because we have the 74 and then we just added. But this is not remedial. This is just another step. Don't be too difficult. Don't be too hard on yourself because Mr. Clean's been with me for a few months now. Right? He already knows how to add and subtract this. Do you have a set class schedule? No. No, I'm just trying to teach everybody how to use the abacus. I have books. I've got books. So if anybody's interested, is it 3 months? It's been 3 months now. Wow, it's been a while. Yeah. So. Yeah, off and on, Mr. Clean has been around 3 months. How time flies. And then school's out, and we'll see how many people will be able to join. So, love learning even though I don't have one yet. Yeah, hey Sarah, I bet that would have been made sense if I knew how to add and subtract on this. Yeah, I meant when are you on? Oh, I'm usually on in the morning and at night. So 8 o'clock in the morning. I'm trying to do 8 a.m. Pacific Standard Time and 8 p.m. Pacific Standard Time because... But this week's been a little off because the kids are all graduating. I know where to put my place finger on which column. Knowing where to place my finger on which column trips me up. You know, and it just takes time, Michael. That's awesome. Thank you so much. Thank you so much, Laura. I got to teach. Don't get scared about how many times I've learned to rewatch videos. I'm going to learn. Yeah. Michael, when you're doing it, you go slow. So when we're doing it, and I know I talk fast, but don't forget, I've been doing this for a little bit, right? So if I'm going too fast, you let me know, we'll slow down. So do you want to do this question again, Michael? Are you okay with this question again, or do you want to do I would have to find a different question. But yeah, I mean, I know I talk fast, and I try to slow down. But that's why it's very helpful to have other people to be like, what? You know what I mean? So there's no harm. Just let me know if I talk too fast. Let's see. Let me do... okay. You know what? Let's go back. If that's okay, let's go back and adding and subtracting. How are we doing? Right? So, Jeffers... I'm not in preschool. Right, Jeffers? Let's talk about this. So did we talk about this, how to add the 5 and how to make a 5? Why are we doing that? Well, you know, when we're doing the adding of the 5, right? The question is do we have enough? If we don't have enough, then we can start utilizing it. Oh, I can make a 5. I haven't seen adding and subtracting yet. I can make a 5. Well, this is adding and subtracting, right? So let's do this one first. So wait, did you create the owl on your cover? I did. Yes. I didn't make the I got the owl and then I modified it. But yeah, I modified the owl. Yeah. But all my books, I created all the covers to my books. You know how to make a 5, but you don't know how to do subtraction. Yeah, modification. Modification! So wait, Jeffers, did we do this? So if I add the 4 and I want to add another 4, do we know how to do that? That book is awesome. Michaela's love. Oh, thank you so much, Laura. Yeah, I'm actually really excited for my minus 10s. It's going to be a blue one. No, I haven't seen it yet. Oh, okay. Here. Let's start with this. So making a 5, we know how to make a 5, right? We know how to make a 5. We have 4 plus 1 is equal to 5, right? So what's going to happen is we're going to do some...
You need modification! Modify! Modify!
So the idea is, on the abacus, we don't have enough beads. Because we don't have enough beads, we need to add the 4. Because we're adding the 4, we have this concept. 4 plus 1 is equal to 5. What's going to happen is we're going to isolate the variable. When we isolate the variable, we're going to do 5 minus 1. What does that mean? I'm going to add the 5, I'm going to take away the 1. Why? Because in this concept, if I give you 4, right? If I give you 4 on my abacus, that's not a problem. But now I need to add another 4. To add another 4, I only have 5 cents. I only have a nickel. Because I only have a nickel, I'm going to give you my nickel. I'm going to take away the 1. So I'm going to add the 5. I'm going to take away the 1. That is what I did. And so my answer is now 8. So what we just did is we took this concept and we modified it, right? We powered it up. And then what we did is we're going to substitute this information to make a 5. We can do it again. So if I have 3, right? If I have 3 on my abacus, I want to add the 4. I need to add 4. I don't have any more beads to add the 4. But guess what? I have a nickel. I have 5 cents. Because I have 5 cents, I'm going to give you my 5 cents because that's more than enough. But that's too much. So what's going to happen is if I take away the 1. So I take away the 1. Each number has a little equation in it. Yes, exactly, a little equation. So as you substitute, then you figure out how to decompose, right? You know how to add and subtract, and then you start going into critical thinking. Every number can be made, but it just depends on what your players are. So when we're looking at our number bonds, right? Our number bond is 4 and 1 will equal to 5. But depending on how you move it around, right? It all depends on how it depends on how it gets placed, right? So if I move my number bonds this way, or if I move my number bonds this way, it doesn't matter. Now we become number flexible. That's why we use this. So when we start doing it, we could do it again. If I have 2 on my abacus, I want to add the 4. Because I want to add the 4, I have enough. So what do? I have enough. I have a nickel. I have 5 cents. If I have 5 cents, I'm going to give it to you. But that's too much. So now I just take away the 1. Now I take away the 1. So my final answer is 6. And we could do it again. So then what you notice is we can do it again. We compound and we practice this concept. I see. Yes, right? Right?
Welcome to the real world.
Clash of Ash. Yes, right? Thank you. I forget where we are in the process, but we go slow and we understand. The first thing we did was we do the adding and subtracting simple, meaning is there enough? Yes, there's enough. The next thing we need to do is understand how to make a 5. How to make a 5 is a very core concept in Abacus, but I don't know why we're teaching it in regular mainstream math. We never use it like the way we do it in Abacus. We can do it again, but we can do it with a 3. When we do it with a 3, we're not going to memorize 3 plus 3. What we're going to do, this is why we look at our add-in. We look at our add-in. Can I add the 3? If I have 3, can I add a 3? No, I cannot add a 3. We always look at the add-in. We do not look at the result. What we're doing is we're adding the 3. I have a nickel. I have 5 cents. I don't have enough. I'm going to give you my 5 cents. So all I got to do is take away the 2 to balance the equation. Thank you, Mr. Clean. You're welcome. I'll see you soon. Yes, Jeffers, thank you. Add the 5, take away the 2. You're going to start seeing a number pattern. If you notice, when I add the 3, this is what I do. And we're going to start seeing this pattern. Because why? As you move the beads, you'll notice when I add the 5, I'm going to take away the 3. Now, if you see the 4, if I had the 4 and I want to add the 4, this is what I'm doing. I'm bringing it all down like this. I add the 4, I take away the 4. And you'll notice that it will happen the same way when we minus the 4 and minus the 3. Because if we look, we have 7. When we have 7, and I want to take away the 3, it's now the reverse. It's minus the 5 plus the 2. So my final answer is 4. So we added, we subtract. It's not a different strategy like we do in mainstream math. In mainstream math, they give you one way to do adding, and they do another way to do subtraction. In Abacus, if you know how to add, you will know how to subtract. It's the same thing with adding and subtracting. You add, you go to the horizontal bar. You subtract, you go away from the horizontal bar. Same thing with adding and subtracting, the 5 and the minus 5. So the concept is, you know that these are pairs. You know 5 and 1 is a pair. You know that 1 and 4 is a pair. So can you add 1? So we have 1. We add 1. We add 6. Is there enough to add the 6? Yes, we add the 6. So my final answer is 7. But not 3 to the 1s column. You can add 3. Can we add another 3? No, we don't have any more beads to add the 3. We only have 1. So to do that, we need to utilize the 5. Does that make sense, Michael? So if I have 3 on my abacus, you add the 5, right? You add my nickel, and you take away the 2. You take away the 2. So Michael says you can add 1 or a 6, but not a 3. Correct. Yes. So you're right. You can add the 1 or you can add 6 if there's no formula. That's correct. Because those are the only 2 numbers I can add, I need to utilize the 5 now. Does that make sense, Michael? That's really good. That's a really good comment. I really do like that. But you're right. Because now what we're doing is we're critically thinking what we can do, right? We're looking to see what can we do. The abacus shows you if we can see it or not. If we cannot, then you know you need to use the formula. Exactly. Thank you, Michael. That is a perfect question. Right? So we have 4. We can do it again. If I have 4 and I want to add the 3. If I have 4, I want to add the 3. There's too much. I have 5. I have 5 cents. There's too much. So what do? I add the 5 and I take away the 2. I add the 5 and I take away the 2. No. Thank you, Michael. That's a really good question. Right? Because that shows that you're critically thinking the numbers, right? You could see the numbers and you could see if you could do it or not. And that's a really good question. Okay, so we could do it again, right? Yes, thank you, Jeffers. We can add the 5 and we take away the 2. So that's what we do is we make a 5. We're making a 5. We're adding the 5, right? And then we could do it again. But when you start looking for the 2s, it's not as many. Because if you look, we have 1 plus 2. Can we do it? Yeah, we can do it. We can add the 2. So we're going to add the 2. That's it. So what's going to happen? We have 2 plus 2. Ha! Thank you. Thank you, Colloquial. So we have 2. Can I add another 2? Yes, I can add another 2. Right? So my answer is 4. Here's when we start thinking. I have a 3. Can I add a 2? I have 3. Can I add a 2? No, I can't add a 2. What do? I use my 5. Because I can use my 5, what am I going to do? That's too much. I got to add the 5. I got to take away the 3. So I take away the 3. So my final answer is 5. We can do it one more time, and that's it. The only other time we could do it is a 4. I have 4 on my abacus, right? I have 4 on my abacus, and what do? I want to add 2. To add 2, the only other way to do it would be add the 5, take away the 3. Add the 5, take away the 3. Joshua. But it's different when you start actively think. And if you have questions, you let me know, because I also know that I talk fast. So that's what we did. So can we do it again with the 1? So 3 is always yes. 3 is always no. Why? Because we only know how to do the 5. No, sorry, we only know how to do the 5. 5 will always be this. However, if I do a 10, and that's what we're going to do next, 7 and 3. So it's not an always. Now we have to start critically think. Can I do a 5? Can I not do a 5? We start going into understanding how to make a 10. So 3 is not always plus the 5 minus the 2. Sometimes 3 is plus the 10 minus 7. Right? And then 2, same thing. 2, yes, 2 is plus the 5 minus 3. However, 2 can also be plus the 10 minus the 8. Why? Because we're making a 5 and we make a 10. That's it. Those are the two specific core pillars you need to know. When you know that down, then everything is scalable. So let's do a question. Let's do a bigger question. Where's my... Oh, here it is. Here. So this number is easy. How do I know? Because if you look, I have 357.8. 578. Oh, sorry, I can't see that. 10,300. No. 3,578. Then what are we going to do? We're going to add 24,311. Can we add the 2?
Yes, we can.
Yes, we can. Can we add the 4? No, we can't add the 4. We don't have any more beads to add the 4. What can we do? We know this. We know how to add a 4. Do we remember how to add the 4? How do we add the 4? Plus the 4 is equal to plus the 5 minus 1. Plus the 5 minus 1. Thank you, thank you, thank you. Thank you, Nat. Thank you, Pay. Right? And then can I add the 3? Yes, I can add the 3. Can I add the 1? Yes, I can add the 1. Yes, thank you, Nat. And then when I add another 1, I'm going to add another 1. So my final answer is 37,889.
Welcome to the real world.
Yeah? Does that make sense? So what happens is now the position that we're in, depending on the place value, it doesn't matter. We are now position agnostic because we know the fundamentals of how to add a 5. Because we know how to add a 5, we can do it anywhere, right? Let's do it again. We can do it here. We know what 26 is. In mainstream school, they're teaching the kids how to make friendly numbers. That's fine, but in Abacus, we don't need to do friendly numbers because we know how the Abacus moves. Can I add the 3? No. How do I add the 3? I know what to do. I don't have any more beads to add the 3. What do I do? What do I do? I know what? I know to add the 5. Thank you, Laura. I add the 5 and take away the 2, right? And then what happens here? I can do plus 2. So we add the 2. My final answer is 58. So what did we just do? We took the concept, the simple concept of make a 5, and we can now scale it. You just got to go through understanding the fundamental. I don't know how old, well, I don't know if you guys seen the old Karate Kid, but the new Karate Kid, right? They say take the jacket off, take the jacket on. Put the jacket on, take the jacket off. Put the jacket on, take the jacket off. It's all about the fundamentals, right? Does that make sense, Jeffers? So it's all about the fundamentals, right, Pei? Does that make sense? I don't know if you guys seen that movie with Karate Kid. Yeah, right? Abacus is life. I can do so many correlations with Abacus. It's so like crazy. Hey KB, welcome. Yeah, right? Makes sense. It's so crazy. It's so elegant and yet so crazy on how, like, it's not more mainstream, and it's just really interesting how not mainstream this is. It's so weird. Decades ago. Yeah. Oh, yeah. Oh, if it's decades ago and listen to this one. Oh, this one.
Now, open your mind to me, please. Open your mind.
Anybody know where that one came from? Anyways. All right, Kay. I don't know if Kay's still here. Thank you. I appreciate that. Because math is supposed to be funny. Okay. So, Kay, I don't know if you're still here. We're going to count. We're going to do a review. When we do a review, we're going to do 1, 2, 3, 4. 4. Total Recall with Arnold Schwarzenegger, right? I don't remember if the Colin Farrell had it. Colin Farrell, right? Yeah. Okay, good. So this is 4, right? On the abacus, this is the horizontal bar. When the beads are touching the horizontal bar, this is what's being counted. So when we look, we have 5. The top bead will always be 5. So we have 5, we have 6. Notice we have 1, we add the 5, we have 6. If I do 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, right? And then we add the 1, now we have 7. So if you notice, this is 6, this is 7. She beats me to the movie because I'm working. That's funny. So this is 7. So we have 7. And then we have 8, right? 5, 6, 7, 8. These are all 7s. So we add the 1 bead, now we have 8. So when I do this is now all 8. And then we have 9, right? When we have 9, we all add the 9. And that's it. There's another one I use. Oh, you know this one, right? Do you know this one?
This is the way.
This is the way.
This is the way.
I think I have like 11 now. I think I'm at 11 now. Okay, did that make sense? So what we just did is this is all 9. These are all 9s. So then when we do 10, now we can start looking at our place values. Every column is a place value. Every place value has all the way to 9. So when we look, we have this. We have our 1s, our 10s, our 100s, our 1000s, our 10,000s. We do 1, right? We did 9. And then after 9, we have 10. 1 and 0, right? This is not 10. This is 55. Why? Because it's 5 and a 5. Did that make sense? That's funny. So, and then what are we doing? Well, we could do 4. We can now count by 10s. We can do 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and then 100. Cool? And that's it. So then what we did is we would look at the abacus and we would figure out the numbers. So this number here, what number would this be? Let me know in the chat what number you think that is. Thank you, Jeffers. It is. It is the year 2025. Thank you, Laura. Thank you so much. Hey, Char. Welcome. Yes, thank you, Pei. 2025. Make sense? So what we're doing is we're understanding how to read the abacus. And then what I did here was I showed how to add the 5. And then we can do minus the 5. And you're going to see the pattern. And it's really quite interesting. So the rest of this book is all about being very specific to answering the questions of making a 5. So this is a hidden word. You answer the questions and then you find what the word is. This one is word problems because I was thinking that these were for kids, and so they might need some help with writing their answers and and tracing the numbers. This is the example page, right? And then I have a color by number where they have to answer the question. Oh, thank you, Laura. See you next time. Thank you, D family. See you next time. So then here's the maze, just like we did before, right? We answer the question and then we follow the path, right? And then we have tic-tac-toe. You make a number. Oh, you find a patch. You add your X or your O and you answer the question. And that's what I did for here. So this is what we call tic-tac-toe. And then we have more mazes, and that's it. Oh yeah, word problems and mazes. And then there's answers in the back. Just in case you don't know, I might need to get one for myself. If you want to wait, I'm trying to build out. A book for adults. Thank you, Michael. Yes, that's a good question. So here, no, you can't. You know why? Because I don't have any more beads. So if I did this, right, I need to add one. I cannot add one more. I would have to do it on this one. I have to do it on this one because I don't have any more columns. I can only go up to 10,000. I would love a book for adults. Really? Okay. Okay. I will get moving on that. I will get moving on that. I need to be comfortable with cuz my mind's about, the kids and stuff. I have to readjust the questions a little bit to not make it so cutesy. All right. So what are we going to do now is we're going to do minus, and then after minus we'll do this question, which is 99, but it would have to be on this one. Does that make sense? The bigger abacus, yeah. The 13 column one I would suggest for the adults just because you can do more questions and you don't need to go from here. But there are some people that enjoy the colorful ones. You can find a 13 column with the same colors. I think it's a little overwhelming. I think this one, it might be for big. No. I have a post that I made with my husband's fat pudgy fingers, and when you move the abacus beads, you just use the edge of your fingers. So no matter how big and burly your fingers are, you should be able to just use the edges of your fingers. This is a standard size abacus. This is not for kids. This is a standard size abacus. So when we're looking, that's why I was talking about you want to just make sure you use your edges of the fingers, right? You want to be gentle, right? You don't have to be delicate because it's made out of plastic. You don't have to be delicate, but you need to be gentle because you want to be intentional as well. When I move my beads, I'm just doing this. I'm not in here, right? Yeah. Yeah, and it's hard to see, right? Because we're like it's face up. But when I'm trying to, that's why I also add that to my little lesson is when you move the beads, that's two. That's all you're doing, two. Or when you do this, right? If you go to my post, you'll see one of my posts like 1 million views. My husband's hands are viewed 1 million times, and it made me mad because none of mine together makes 1 million. Anyways. But if you look at my post, you'll see his fingers. And what we do is we want to make sure we just want to go the edges. Right? Oh, made me so mad. Anything he does. Oh, I like the color ones better. Yeah. I have to go. See you later. See you later, Clash of Ash. Yep. Yeah, the colored one is better to see. But I think if it gets too big, it gets a little overwhelming. So I actually added this thing where I called it a column isolator. So we can focus on the columns. And we'll do that for the bigger number. What I want to do is I want to go into how to make a 5. Yeah? What we're going to do again, we're going to minus the 5. And so this is the next set. The reason why I broke it up this way was for kids, right? Ages 4 to 9. And then they have practice, and they practice all of this. We can go through it a little bit. So okay, here we have 4. Now you'll notice that we're going to start seeing a number pattern, right? When we have 8, and want to take away the 4. To take away the 4, we have this to substitute. We know this. Minus the 5 plus the 1. We see this before, but now we're doing it reverse. Does that make sense? Hey, Mimo! Welcome back. So what we're doing, right, we want to substitute minus the 5 plus the 1. But then when we add, right, we want to add the 5 minus the 1. So what we're doing is we're compounding our information. We are now practicing and compounding our information. We're not learning anything really new. It's just the opposite. So when we add, we subtract. And we can do it again. And so we have 16. We have 16 on our abacus. and I want to minus the 4. Cannot minus the 4. What do? Minus the 4 is minus the 5 plus the 1. I want to minus the 5 and plus the 1. That's what I did. Minus the 5 plus the 1. My final answer is 12. Right? Whew. So what, we could do it again. We can do 15. 1, 5. This is 15. And then what? We want to minus the 4. Jeffers. Oh yeah, not a problem. Thank you, Jeffers. Have a good day at work. Thank you for joining. So what we do is we want to minus the 4. When we minus the 4, what are we going to do? Minus the 5 plus the 1. And my final answer is 11. All right. So those left. Everybody else have left. Who else is here? Hey, JB. If it's positive, you subtract. If it's negative, you... No, because it's together, right? Oh, if it's positive, it's the 5 that you want to look at. If it's positive, it's the 5 you want to look at. Because what we're doing is we're adding the 5, or we take away the 5. Does that make sense, JB? So when we're looking, when we want to, see, there's a little bit here. Oh, hey, KB, thank you so much. I didn't realize you were still here. Do you want me to go back to doing this one? So, JB, did that make sense? When we do the 4, we're doing both adding and subtracting. Right? 5 is too much, so you have to give back the difference. Yes, thank you, Pei. I didn't realize you were still here too. Yes, you have to give back the difference. You want to balance the equation, right? So you know what? Let's go back a step. Let's go back a step and let's doing adding again. I don't know, Pei, were you here for that? So what are we going to do is we're going to add 4. I know Pei was. We can do that. So it's 4. When we add the 4, we want to add another 4. Right? Yeah, so what Pei talking about is we're going to add a 4. I'm going to add 4 to the abacus. I add 4 to the abacus, right? I want to add another 4. I came in with the adding, ended the adding. Okay, so here I want to add 4. When I add the 4, I want to add another 4, but 5. I have a nickel, but it's too much. 5 is too much. So what do? I take away the 1. So now I'm left with 8. So we can do it again. We add the 5, and we take away the 1. So since you can't add the 4, you have to get from the 5. So here, the way I have it in this book is I go to the cats in the tree. If I have 4 on the abacus, I don't have enough to add another 4. I go to the 5 cats in the tree. I grab 4 cats, but then 1 cat runs away. So then I'm left with 3. So 5, I go to the cats in the tree, I add the 5, and then 1 cat runs away. So my final answer is now 8. Yeah. Cats in the cradle, not in the tree. Ha 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 ha. Hey, Babble, welcome back. It's been a minute. Does that make sense? Yeah. Cats in the cradle. That's funny. All right, and we could do it again. But then now what we're doing is we're focusing on practicing this concept, and we just practice it again, right? So we have the 3. I want to add the 4 because I don't have enough to add the 4. What do? I give you my 5 cents, but that's too much. I need change. I add the 5. I take away the 1. I add the 5. I take away the 1. So my final answer is 8. Hello. Mimo, are you still here? Is this review for you? A bit of social media vacation. I will be soon. I'm gonna be going camping. Yeah. It's good. It's good to take a little vacation from stuff. Okay. So, and then we could do it again. I don't know if JB is around for this. So that's why when I that's when I went and did this, it made a lot of sense, right? Because what we did is we understood how to make a 5, and now it becomes versatile. So we could do this one again, yeah? How do you count on this? So let's do a little review. Okay, let's do a little review. Thank you, smile everywhere. So when we're looking, we want to count 1, 2, 3, 4. This is 4 on the abacus, and then we have 5. Every time the beads are touching the horizontal bar, this is what's counted. So we have 5, 6, 5, 6, 7, 5, 6, 7. Right? We do 7. These are all 7s. And then we do 8. That's what 8 looks like. And then what happens? We do 8 all over. We do 8, 8, 8, 8, 8. And then we do 9. 9, right? These are 8s, this is 9. So we can do 9 like that. That's it. So when we look, we can do place values. Every column is a place value. We have our 1s, our 10s, our 100s, thousands, 10,000. So when we count, we do 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. That's it. 10, then we can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. Make sense? So we can do this question. We can do 283. And then what we're going to do, we're going to add 511. Can we add 511? Yes. So we add 5, we add 1, yes, we add 1, yes. So our final answer is, what answer is this? What is my answer here? Hello, user 397, welcome back. If your add, subtract, multiply whole numbers, can you repurpose tens? Yes, you can. Yes, you can. Thank you, Pay. 794. That's why, yes, thank you, Greenleaf. That's why I say learning this learning the formulas now becomes position agnostic. You're absolutely right. Yes, thank you, Kay. It is 794. 794. And you'll see it. So we can do it again here, right? Notice, oh, we did this, right? We did this. You were here for that. But yeah, it becomes now position agnostic. So if I have 26, I don't need to worry about being number friendly. I just need to know what my formulas are. I want to add 30. I want to add 6. Can I add, I'm sorry, 2. Can I add 3? How do I add 3? I don't have enough beads to add the 3. But guess what? I have this 5. So what am I going to do? I'm going to give you my 5, but it's too much. Right? I'm going to take away the 2. So my final answer is thank you, Pay. Right? Plus the 5 minus the 2. And then can I add the 2? Yes, I can add the 2. So my final answer is 58. I got your abacus materials in the mail. Whoa! Awesome! So excited to get started on this summer. Yeah, right? Thank you so much. I hope, you know what? Let me know how it goes. I'm really excited for you. Greenleaf. Yes, thank you, Greenleaf. It is 58. 58. Yeah, you're welcome. Thank you. It's exciting. Okay, cool. So that's what, I mean, now it becomes position agnostic. Now we can go pretty much anywhere as long as you understand it. So we're done with this. We can do one more and we'll have to make a 10. Are we ready to make a 10? So we understand how to make a 5. So wherever is too much isn't counted in the end. If it's too much, you have to find another way to get it. Right? So like, if it's too much, isn't counted in the end. It is counted. It's just, we just have to do some.
You need modifications! Modify! Modify!
So, Jose, just so you know, we have our number. This is a concept that we teach the kids, right? We teach the kids how to make a 5. But in Abacus, we utilize it. So what's going to happen, it's kind of too much. You're always counting in the middle. So what we do is we substitute 4. 4 gets substituted with 5 minus 1. I count in the middle because if you could see, there's a dot right here. This dot is my ones indicator. So with my ones indicator, I'll go like this. My ones, my tens, my hundreds, my thousands, my 10,000. Sometimes I go here. Then you move everything over to here because I have a dot here, right? So I have my ones and my tens. That's how I see it, right? But it's different because your screen is so small, right? You can't see all the nuances, but when you have your own abacus, you'll see that there's these dots, right? And if you notice, they're grouped into threes. So it doesn't matter which dot I'm at. It just matters where I'm going. I could do ones here, 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 or here. It doesn't matter. But what we're doing is we're understanding that if my ones is here, I know this is going to be my thousands. Then this will be my millions. And then this will be my trillions, right? There's dots here to help you label. So then you don't have to keep counting and recounting because labels are nice. So just like using a nickel, but you have to give back what's taken over. Yes, exactly. So then that's the thing. That's why I use a nickel, because the concept of the 5 is what trips up a few people. So the nickel makes sense because we've seen money before. As adults, we've seen money. Do I use this for kids? I don't use this concept for kids because they may not know what money is. So that's why I use the cats in the tree. Does that make sense? I get it now. That's amazing. Yeah. Ask your questions, Smiles. Ask your questions, Smile. Yeah. Because why? Because everybody comes into the conversation, right? And I don't know where you are in my conversation. So, yeah. But yeah, and it becomes very elegant when you start understanding the fundamentals of the abacus. And what we're doing is we're doing fundamentals of the abacus. It takes a little bit, but at least you can start compounding it and we can now scale it, right? Just like we can scale this. That's why I did this. And that's why I started here. I have my hundreds, tens, and then the ones. Yeah. I need to find another bit. Knowing is half the battle. That'd be funny. Right. Okay, cool. So one last one is how to make it 10. Oh, so did that make sense? Who was it? Jose, did that make sense? G.I. Joe, right? G.I. Joe. I gotta get that. Yeah. Okay, that makes sense. It's nice you got my follow. Oh, 2 5s. 2 5s. What? I don't know what we're doing. 2 5. Yeah. Thank you. Smile everywhere. Yeah. I mean, the questions, it's helpful to understand where we all sit, right? Because coming into a conversation, I'm in the middle of a thought and you're just trying to catch up. So it as long as you let me know where you are, then I can always reconvene or review. So, Jose, did that make sense? Minus the 5 plus the 5? So we can move on. Are we going to move on or should I continue on with the adding of the 5? That makes sense? For new users, decimals are easier to visualize if the dot was between the ones and the tenths. Yeah, I got it. But it's not a decimal. It's a label. You're right, but it's a label because I don't have another decimal. Why would I have another decimal here? You know what I mean? So that's why I'm very specific with my words. Does a standard abacus have 2 5s on? You explained it perfectly. Thank you. Oh yeah. Hey Johnny boy. Thank you. Oh thank you. I appreciate that. The standard abacus is not standard, right? Standard abacus just means the size. This is a Japanese abacus. We also call it a soroban. This is a Chinese abacus. This is called a swapan. Swapan. Or a Japanese abacus is a soroban. Right? User 397 knows. User 397 knows. Right? So it's the same thing, but what happened? The Chinese one was before in the timeline. The Chinese one was before the Japanese one. So then Japan came around and said, "I'm going to make it more efficient," and they made it more efficient. Now this is the modern abacus. Everybody uses the modern abacus, but before the Japanese, I think this came around maybe in the 1970s. I don't know for sure. I don't know for sure. Yeah, I've been researching. I don't remember when it came around. Maybe the 70s. I don't know. But the Chinese one it uses almost the same. 1, 2, 3, 4, 5. Because we have 5, we're going to trade it in. We trade it in, and now this is 5. We do 6, 7, 8, 9, 10. We trade it in, and now we have 10. So 5 plus 5 is 10. We're going to trade that in and do this. And it's the same thing. Kind of, right? So we have, but we don't trade here. We do 1, 2, 3, 4, and then 5. 6, 7, 8, 9, and then 10. That's it. I've been researching. Yeah. And it's funny, there's not a lot of information out there. There's not a lot of information about the abacus, which is very interesting. Yeah. I've seen anime use abacus, and they're using it correctly. But I see the American movies, like Soul, and what? And Penguins of Madagascar. They use a different type of abacus. The modern Japanese is better because it doesn't duplicate some numbers like 5. It's just a different way. User 397. It's just a different way. Oh, okay. Can you count from 1 to 0 on the abacus? Yeah, not a problem. So when we're doing it, right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. There's 10. 11, 12, 13, 14. 15, 16, 17, 18, 19, 20. And then it goes back again. 21, 22, 23, 24, 25. Yeah. Yeah. Sometimes it's just, we need to just understand it more. It's just something unfamiliar, right? So now we can do 25, right? 25 point, how do I know? This is my ones. Point 34. Point 34. So now what we just did is we just did decimals. 25.34. Because if this is a decimal, right, this is not a decimal, this is a label. The label is ones, right? If we did it over here, it'd be 25.34896. 25.34896. That's the difference. Cool. Okay. How are we doing? Thank you for the follow, Michael. Wow. Thank you guys so much for the hearts. 12,000. Thank you so much. I appreciate that. How are we doing? How are we doing? Any other questions? Oh, thank you for the follow, Jose. Yeah. I have workbooks, if you're interested. I have workbooks. My name is Lynette. I also sell it on my... Yeah. Oh, I'm missing an N. Yeah. Swan Pan. I can't even... That's a hard name. Yeah, that's what it is. Yeah, that's the Chinese one. Yeah, so my name is Lynette Thane. My name is Lynette Young. I have books here. I have books at the TikTok shop. And if you're interested, um, what else? I've been teaching Abacus for 20 years. I have 3 boys, and they all have gone through Abacus, but they haven't gone through my worksheets because it's tough to be a young parent with 3 boys. But they all know how to use the Abacus, and I believe it's the greatest thing next to sliced bread. I appreciate everybody here. Thank you so much for joining. Oh, you know what? And if you're interested in a reference sheet for the Abacus, there's a link at the bottom, and this is the reference sheet. It will look something like this. I believe there's a link in the bottom if you would like. It is free for you if you guys want to. Let me see if I can find it. Yes, thank you. Thank you. Are you on live tonight? I should be. Today's Wednesday, so I don't see why not. It just depends on whether or not I am. I should be. I will be. I will be. Let me take that back. I will be. But yeah, because you follow me, you should be getting a notification. So here, yeah, here, if you want the free worksheet, to get the free worksheet, there's a little button here that says service. Click on that, and you will see to give me a DM me, and I'll send you the link for the worksheet. Yeah. So, thank you guys. Thank you everybody. Teacher Lynette, you inspire me so much with teaching me. I went and bought all her workbooks. Thank you so much, user 397. I appreciate that. Oh, just so you know, I'm not going to be on live tomorrow because I have a graduation to go to. So tomorrow will be a little bit wonky because tomorrow is graduation all day. Thank you. No, thank you, Pay. I appreciate that. Thank you, user 397. Yeah. Happy camping. No, not camping. Graduation. I like this. It's actually very interesting. Thank you, Jose. Thank you, Jose. Oh yeah. So here it says you can sign up for some free worksheets. It would look like this. It's a reference sheet. You can have it, and then just send me a message, and I'll send you the link. There we go. Yeah, yeah. I will be around. I'm just tomorrow is graduation, so I'm not sure if I'll be on or not. Just so you know. But thank you everybody for joining. I appreciate everybody commenting and being having a conversation. It's always nice to have a conversation with people, you know. And I appreciate all the questions. The questions are fantastic. Thank you. Bye, Pay. Thank you so much. Bye, Michael. Thank you, Jose. I'll see you. Oh, and I'll see you tonight. I'll see you guys tonight. Parker doesn't care anymore. Parker, have an awesome day. You too. I'll probably be on tonight for sure. For sure, I'll probably be on tonight. I think so. Yeah. Thank you again, Parker. Have a good one. I'll see you later. See you later. Bye. Bye, everybody. Okay.